hardware and to do it with flight hardware, and so that went really. And it worked flawlessly yesterday, and so that air injection that we had for the service module purge really well while we had the closeout crew out at the pad, and we were able to do a full closeout. We got to go do, and we're going to go do it. We'll figure it out. And we're going to target our next wet dress and the results from that. And with that, I'll hand it over to.
For us to get the integrated stack for Artemis II, the oxidizer and the fuel, and get to the count. And for the team, relative to performance, rocket to talk to us, and it did just that. It was an opportunity for us to ring out the system as well on launch day. The rigor that our teams put into reviewing the data, they stay home this morning about looking at data and going to the MMT. The MMT was in place, providing guidance to the launch director. As well as the go for terminal count, which I would say were minor risk acceptance items. That's that's the big part of what the MMT does. Is it improves risk or not. The agency's decision and the plan we've got moving.
Questions. We'll start here in the room, and then we have several already. You can get into the question queue with *1, and with that.
Hello, Marcia Dunn, Associated Press. 3 years seems like a long since Artemis I, and just explain how you can still be having the same problem.
In my old job as the course the we had with the leaks, we took a pretty aggressive the seals and try to understand their behavior for surface finish and so we got a good handle on that relative to the flight side and the ground side interface. On the ground, we're realism we can put into the test. and what I would say to that is, interface is a very complex interface, and when you're dealing with high for that reason, and we do the best we can. Initial things that we were seeing, and the technical team or some sort of deformation or debris.
At this point, we did make some changes, while not to the valve. We had a leak there. We did a design mod. It worked great. In what I would call the back of the plate in the purge can, and that plate, we took the way that some of the hardware improvements we made during Artemis I, but we did make overall leaks there yesterday. So those two areas were, and they tested out really well yesterday. And it was the first chance we got to do that.
Thanks very much. Bill Hart with CBS News with three very quick but related questions. What is the earliest you think you could do another WDR? No, that's an open reason. Would that rule out the March window? And finally, up on launch day, and you got the tanks filled using your technique, and you never with the original leak, or was that a we're out of here no matter what on launch?
Launch day, if we were able to use our haven't gone and done the deep dive on all the timelines to see exactly where we would have landed launch day within our allowable 16%. Could have been go for launch.
Yes, I'll take dress rehearsal. We are, a few hours off of a lot of data they need to assess. We need to put together what the plan is. What else do we want to do between now and then? So there's a variety of things that need to be taken into. I'll make sure everybody knows. I don't expect it'll take us too long to get to that point. Plan. We do believe that we at this point that the work that's in front of us can be conducted out at the pad.
So I would say a couple things, right? During Artemis I, we found out that we can demonstrate that again for Artemis II, but we so that's I would say the first order of business this afternoon when we're that would take and how we'd get into that configuration. Of course, the first part is I think, yes, we can do that out at the pad. The other is that we could do our FTS reset. And we have it laid into our nominal plan should we need to
and then we'll go to a few on the phone.
Hi, everybody. I'm Jamie. At least until launch. How's the pressure feel amongst yourselves to finally administration wants to land on the moon in just 2 years? Thank you.
We put that pressure on ourselves to be successful. We don't feel any schedule pressure on we're going to get from flying SLS and Orion again. There's not, from the production side, there's, of course, we're doing major development activities with the lander and the spacesuits, which are be delivered to the Cape. At least the top 4 fits will be delivered here in a few months. They're in TVAC testing right now. They're ready to be joined. All we have to do is that production activity is occurring separate from the launch. So we'll have to cut that into the design, and so we're just
before coming back here into the room, and we'll start with Jeff Faust with Space.
If you could provide a little bit more details about the hatch issue that you reported going on, and why is the hatch closure the top priority you wanted to check out in the wet dress? Thanks.
The reason we wanted to check out the hatch during the wet dress time, but the environment's a little bit different being out at the pad. There's something unique and different about being out at the pad in a cryogenic. We wanted to take that opportunity to have the hatches. There's 2 of them. First off, there's 2 of them to go close out, folks. And the timelines associated with that. This one's a little bit different because you got to get the crew module barrier out, which is it serves as kind of like the. It's multiple components that come out, and then there's just the close. It's a timeline and a waterfall of work. I don't know that there's any one thing. We're always monitoring that work because it does.
All right, we'll take another one from the phone from.
Thanks. Questions for anyone. I just wanted to re-ask Marcia's question. Like I said, why wasn't this detected earlier? Clarity on the Orion closeout work. I know we just talked about the Orion issue. Extended Orion closeout work, and so what is
it's a good question. As we said, we tested the component level, right, and we made the improvements we made from our part of I think what might be contributing to it, and we have to go inspect the seal and service mass, and we roll. That rollout environment is very complicated. So, and when we're rolling, that interface is hard to predict kind of what credit we can take for and what the acceleration environment. To see if we can characterize it, but even then, it's pretty complicated from a stress first configuration in which we've been able to witness that environment. The pad, you know, we have a very good understanding of like onshore winds and those loads. Very hard for us, and we kind of keep in our pocket as you know, pretty constrained about that, because we can't take credit for the witness of that rollout environment. It's very, and see what happened, and I'll leave that for the Orion question for y'all.
If I'm following the question correctly, the amount of work in Orion wanted to limit the amount of work between WDR Orion. There really wasn't a whole lot left between WDR and launch. Final configuration for launch relative to some of the crew equipment, but configuration yesterday.
Okay, we'll take one more on the phone. Ars Technica.
Hi. Out of DSLS, the flight rate is the lowest of any NASA-designed vehicle. Going back to the green run years ago, I think that this is maybe so I'm just wondering, given the low flight rate, an experimental process. Thank you.
I'll take that. Long 3 years. It was brought up by Marcia earlier. You know, that's a long time between the first design to conduct these all-up tests. We do component and other level testing. So we do get that data, but you know, to be fair, it is going to be experimental. Every time we do it, these are very bespoke components. They're even though they're within tolerances, each one of them is different. Honeycutt said earlier, you know, to cryogens and how it breathes and how it vents and how it wants to. Separately, you know, this is the configuration that we need. Making sure we achieve the objectives of the campaign using this, but also making sure that is exactly the approach we need, which is why we're pushing for this test. This is Charlie and Lori and the guys get ready to go.
Go to this side of the room. We'll start here in the front.
I feel what you saw yesterday with the hydrogen concentrations and the 5% or somewhere in that neighborhood. Did you see elevated? Did you see a change near the point where you tripped the limit? And then line and the bleed line, either in that bleed line, is that what is that what possibly tripped the limit during terminal?
Let me start there. So, you know, what we have learned interface is sensitive to flow rates and pressures. We learned that we saw the same thing yesterday. It was when we went to fast fill. We were in slow fill. We fast fill. that we began to see the limits creep. We did, was it a steady rate? And then when we tripped got close to the 16%, and decided to invoke our procedure for letting Artemis I, we found that sometimes that was very successful. I mean, that's a pressure across it, you'll see the seal improve. And so that was the goal. Similar. We have the ability in what we do in that case itself, and we're kind of using that pressure to, hydrogen light and push it, as we say, push it up the hill. And so we saw to see the leak. And so it was, I would say, in and around the 12. Saw that through the 3 different contingencies, but we were able to manage it. We or get close to it, and so that's how we managed to get all the way to in the leak. It was in terminal count. It was as we began to through the 8-inch or the 4-inch bleed, we in a few days when we get in there. So it'd be hard to say at this point. Again, right now I'd tell you that based on the timing, that it was likely through the 8-inch and see what was going on there. But it did go up, and it went up very. The operator immediately gave a cutoff, and we got into safing.
We'll take a few more from the phone.
Hi, Irene Klotz with Aviation. You ended up adjusting the timing for the wet dress. If there was any equipment or systems that were close to qualification. The Falcon 9 upper stage anomaly yesterday do anything?
SpaceX did a report as soon as it happened on a Starlink flight that they had an upper stage anomaly. The lead investigative body, we do have our teams with commercial crew embedded, et cetera. We're pressing towards our crew 12 window. We're planning. That's going to be contingent on the return to flight rationale, which we're heavily partnered with.
All right, the 2 days that we delayed wet dress. So I'm really proud of the team that worked so hard. What we could do to get there early, our team had the work done 2 days earlier than we actually did it. And so that was the weather wasn't so wonderful, right? We were in unprecedented looking at the weather and determining if we were in a would have been our T0 would have been Saturday evening when we ended up doing cold, and it was very windy, and we did look for a wet dress, which is different than launch. On launch day, you absolutely did look at our temperatures because we needed to determine if we were with flight hardware, and we looked at winds, and winds was really the more concerning. We were looking at as our constraint, and that was the in the state of Florida during that time, you know, that we had 50+ knot winds on Saturday night. It certainly would not have been a good configuration for us to send our closeout crew to the pad for moving it. In terms of how did things go, equipment, right, that is sensitive to temperature. We have, as part or EREG control that accounts for changes in temperature. Significant that I would say came out of yesterday, other than, you know, active in the vehicle. We had purge go into the outskirts. Sorry. We had purge go into the vehicle. We had all the right things in place.
A question first to Charlie and then a second to Amit. Troubleshooting issues regarding to audio comms across the ground teams that have been characterized, what those were, and are they the same or different than what we're seeing? As you're looking towards the future of SLS, for that in the somewhat near future, can you talk about some of the planning in the bud for that second version of SLS that's coming down the here? Thanks.
That's more efficient. In fact, we came up with a unique to make that a little bit better. We'll see how that works. But you know, across the board, too. I mean, these are big circumferential welds. You know, the diameters, and so we're learning those things both in Michoud and we're configuring the rigs. Is a little bit different, right? As was pointed out earlier. I'm reminded again, you know, for almost 4 days and 40 years from Challenger. So, Charlie.
Yeah. So the comm issue that outage in LC-39 with the ground communication system made across our teams, both here at Kennedy and then back to our support center. And then I'll say a suite of experts to go look at what might I'll say a series of events that within the, and I'm probably not the right person, the kind of the details of the code taken out our one of our LC-39 experts, including the supplier of this equipment and NASA experts from across to diagnose the root cause right away, put a series during the wet dress rehearsal. And wet dress and launch, when you're doing a single test, you might have a handful. Maybe you've got centers across the country. We're all tied together. And it worked really well. So the team did a great job resolving that issue.
Hey, thanks, Rachel. Maybe for Charlie, did not get to practice. Get closer to or hit that 33 second.
I'll take it. Well, let's talk about the things that we did. So we loaded the core stage. We loaded blocks, upper stage and core. Got to we wanted to get inside of terminal count ability, which is that you've got all of your cryoprop systems for up to 3 minutes, and we wanted to demonstrate that capability. Is we would go down, have a planned cutoff in the demonstrate that within the launch window. Didn't get a chance to do that, and thereafter. So I would say those are probably the three things that to do, and we'll target doing those in the next wet dress.
With NBC News.
Hi, thanks. But I was curious if you have any early indications yet about whether are there launch opportunities beyond April that are available?
As I said earlier, right now it looks like the as far as the launch opportunities, I know we've published what those opportunities. Publish those for February, March, and April. We've got opportunities. If necessary, we'll go beyond that. But yeah, there are opportunities. We constraints that determine just how many days within the lunar month we have. The order of about 5 or 6 days. It'll be something similar.
Okay, next.
Hello, and thank you very much for taking our call. 1 and 2 have phased. Will this reinforce NASA's which was something that then acting Administrator Sean Duffy.
Yeah, sure. So we're, of course, heavily partnered with integral to our architecture. So we're going to continue to partner with them. That's certainly true. Changing commodity on SLS probably disable the production significantly, and make a change. You expect a change. We're in a lot of these tests, and so now putting a big design to do is let industry innovate on their own machines, and then we need to.
Okay, next on the phone we have.
Thanks so much. Could you tell us how long you can keep batteries on the flight termination system? Is that still an issue this time, or have you?
Yeah, so there are some clear about the pad access that we now have available for Artemis II. And do servicing out at the pad. I will say that cryogenic propulsion stage, our upper stage, that those. So that if we go beyond the March those batteries, that's anticipated right now. So.
Okay, we'll take one more on the phone and then come back into the room.
Hi, thank you so much. Just a clarification question. You mentioned the quick disc. And is it a piece of ground equipment that would have been refurbished or replaced?
It's same heart parts and things like that to get refreshed.
White sweater.
Jackie Waddles with CNN. A question for Mr. Honeycutt. You mentioned that there were how the MMT discussed and what you communicated.
Yeah, conditions versus testing in wet dress conditions, the majority of being out of limit just a little bit, and that flight, they were pretty minor, but our commit criteria, taking a waiver or there's risk acceptance, bring that forward to the MMT.
Okay, we'll come on.
Albert with the Launchpad from Canada. For Charlie, looking forward to the next for if we get into tanking, what the limitations to recycle for hours. Also looking towards the vehicle, are there any waivers? One was the SRBs. Are we approaching any of those cutoff timelines that we
waiver pieces, but I will talk about the address that we do, and the first is or the plan window, provided that you have enough window to do this. If you had an issue you have the ability to go get back into fill, get your tank, work your way through, and then retarget a new T0. That is, thankfully on Artemis I launch night, we came through terminal count without Again, it's part of our normal sim cadence is to. So we wanted to demonstrate that. So that recycle, you are going back and you're going to retarget another T0 within that same 2-hour. And yes, we do have a very different capability. You know, we utilize somewhere between, depending on when you scrub, somewhere between losses just in boil off. And so you have to replenish that. And of hydrogen that we had to roll into the pad. We did about 20 8-hour scrub turnaround. That also puts a big demand on the suppliers. That's a tough. The new 1.4 million gallon hydrogen sphere, again, first we intend to load the vehicle, and we use the old sphere to store hydrogen. We can push a couple of 100,000 gallons of hydrogen from that new hydrogen sphere.
Yeah, probably the booster office does a really good job of state estimates. So for the near term, we're still good. Some of the other areas you've already heard about batteries, and then saw about batteries, and then saw items. So I don't see any concern out there right now.
28 on the boosters, I think, for this pair, and then Sloan measure that as we go, so we can actually take witness and see if we're getting it on the spacecraft, like the active the scrubbing through the middle of 27. So we got a lot of margin there.
The next question from Alicia Sowers with Mashable.
Ground communication dropouts, but since that's already been answered, being completed, is there increased risk? Electronics on SLS through,
Take a shot and I'll hand it over to Johnson. One of the things about having rated for hydrogen at minus 423 degrees, 5 to 27, there's certainly things we take into account as it relates to the purges on the vehicle.
You know, when we go through our testing and certification, that we could experience out at the pad, you know, and even King coming through, we did the assessment and we said it. Yeah.
I also said lighting protection, you know. I think, you know, the vehicle's pretty robust against those conditions.
Paul Brinkman with Aerospace America magazine.
Explain in this context how the leak threshold what exactly is the risk of a leak at 16%? You know, the
Or John, if you want to add.
Yeah, what I would tell you, you know, get about why we had such a low requirement at 4%. We challenged the team to go back and do what I think it helps you to understand vent coming out of them. Obviously, it's some a leak. It mixes with the purge, and then it vents to atmosphere. Or operate in what some sort of a small flame front that can't. And when we did those tests, and it was fascinating to go. But that's where we got comfortable with associated with that too. If you get something else, go ahead.
I was just going to say, SLS program, they came up with a test campaign. The purge in the cavity and introduced, and this was within could not, and that's what the limits were based on. It was based on
time we have for today. I want to thank our participants for being here today. Artemis blog, so you can stay tuned there for additional updates. And thank